Hello, everyone, and welcome to the Environmental Finance Center's Wastewater Treatment Works educational video series. My name is AJ, and I'm a research engineer with the Southwest Environmental Finance Center, and today's video is all about unit conversions. Today, we'll be going over the best strategy to complete math problems requiring you to convert units of one type to another. Unit conversions are essential to understanding many of the other topics covered in this series, and we recommend practicing and becoming comfortable with unit conversions in order to be successful at wastewater math. This lesson is intended for wastewater operators and will cover typical units used in wastewater operations, such as units of distance, time, and volume. With that being said, let's get started. We will first list the strategy for converting units we will be using today and the steps involved in that strategy. And then we will practice this strategy with a couple of practice problems. As you may have noticed, the list of steps we'll be taking for our unit conversions is currently on your screen. Our first step will be to identify the given units. The second step is to identify the required units or the units you want to convert to. Then we will determine our appropriate conversion factors. After that, we want to set up the equation so that terms are aligned horizontally. This will help us keep them in order. And then we want to cancel our units. And then we want to multiply across. So canceling the units will then help us assess our results and make sure that we have the correct units that we want to convert to. So let's go ahead and apply these steps to our first practice problem. How many minutes are in one day? So our first step is to identify the given units. So we are given a term of 1 day. We identify the units that we want to convert to, and that is in minutes. Our third step will be then to determine the appropriate conversion factors. So we know that there are 24 hours in 1 day and 60 minutes in 1 hour. So our next step, step 4, is to set up the equation so that the terms are aligned horizontally. As you can see from the problem in the bottom of the screen, this has already been done, and we set these up as fractions. It may not seem necessary to write the numeric values in these fractions because it is in the numerator for each of these terms, but this is important for later, more complicated problems. And our next step is to cancel the units for our conversions. So since day is in the numerator of the first term and day is in the denominator for the second term, we can cancel that. So we cross them out. And the same thing for hours. In the second term, it's in the numerator or on the top of the fraction, and it's on the bottom of the fraction for the third term or in the denominator, and so we cancel that out. So now all we're left with is minutes. So after we cancel our units, we can go ahead and multiply across. We have 1 day times 24 hours times 60 minutes. And we canceled all the other units already. So the only thing left is minutes. And this will give us 1,440 minutes, or abbreviated to min. And this is where we assess our results. And we can easily do that because we already canceled our units. So we know the days are canceled out, the hours are canceled out, and all we have left is minutes. So this should be correct. And so that's how we convert a simple day to minutes problem. Okay, let's go ahead and try something a little more difficult. The next problem reads, a wastewater plant measures the velocity of their flow at their discharge point. The measured velocity is 10 meters per second. How fast is this in miles per hour? So we're going to use the same strategy as we did in our previous problems. And we're going to identify in the first step our given units, which for this problem is 10 meters per second. Then we're going to identify the required units, which for this problem is miles per hour. Next, we want to determine our appropriate conversion factors. We're going to first figure those out for converting miles or to meters to miles. We're going to first figure out converting meters to miles. So we'll use feet to meters. 1 meter equals 3.28 feet. And next, 1 mile equals 5,280 feet. Then we want to convert seconds to hours. And there are 3,600 seconds in 1 hour. Next, we're going to set up the equation so that the terms are aligned horizontally. So first we have our given units, 10 meters per second, which we multiply, and we have 3.28 feet over a meter, and the meter will go in the bottom part of our fraction in this one because it is the numerator on the first one. Okay, now we want to go ahead and set the equation so that our terms are aligned horizontally. Now we want to go ahead and set up our problem so our terms are lined up horizontally. First, we have our initial unit, 10 meters per second, and we're going to multiply that by our first conversion factor. We'll have 3.28 feet over meters. Meters is the denominator in the second term because it's the numerator in the first term, so we want to be able to cancel those out. Next, we are going to add our miles to feet conversion. Again, because feet is the numerator in the second term, it will be the denominator in the third term. Then we add our time conversion factor. It will have 3,600 seconds per hour, and seconds will be the numerator in the fourth term to cancel out the denominator in the first term. And then we just multiply across. We multiply 10 times 3.28 times 3,600 and divide that by 5,280 feet in our calculator. And this will equal 22.4 . Okay, after we've aligned the equation horizontally, we'll go ahead and cancel out our units. So meters cancels out meters, feet cancel out feet, and seconds cancel out seconds. That leaves us with only miles in the numerator and hours in the denominator. After that, we can go ahead and multiply across. We multiply 10 times 3.28 times 3,600. Which is divided by 5,280. And when we put that into our calculator, that equals 22.4. And we add our units back in, which is miles per hour. Or that can be written as 22.4 mph. And as you can see, we did that beforehand and just set the problem up and multiplied it across, and we get the same answer. Okay, let's go ahead and apply this strategy to another problem. And this one reads, the Albuquerque wastewater treatment plant measures their influent in millions of gallons a day. Their average influent flow is 55 mgd. What is the flow in cubic feet per second? So first, we're going to identify what we're given. This is our 55 mgd. Second, we're going to identify what we need to find. So this is going to be our cubic feet per second. Then we're going to use our conversion factors. So first of all, 1 mg is equal to 10 to the 6 gallons. 1 gallon is equal to 7.48 cubic feet. A day is equal to 1,440 minutes. And finally, an easy one, a minute is equal to 60 seconds. So next, we're going to arrange our equation so these terms are horizontal. Okay, our next step is to arrange these units horizontally. Our first one is going to be our 55, our value of 55 millions of gallons per day. And our next unit will be to convert the millions of gallons to gallons. So per million gallon, there's 10 to the 6 gallons. Per gallon, there's 7.48 feet cubed. So that takes care of our volume. Now for day, there's 1,440 minutes. And per minute, 60 seconds. So we can go ahead and cancel out our terms. For the first unit conversion, our millions of gallons went on the bottom because it's the top of the term for our initial value. And that's the same for the second and third with our gallons. That leaves us with cubic feet. For days, it's at the bottom of our initial unit. And for our third conversion, it's at the top. So we can cancel that. And we cancel our minutes in the same way. And that leaves us with our units, cubic feet per second. And then we're just going to go ahead and multiply across. And this calculates to 85.1 cubic feet per second, or 85.1 CFS. So that concludes our video today. And again, my name is AJ, and this has been the Environmental Finance Standard Network's wastewater treatment video series. And we'd appreciate it if you join us again.